This is Dee Dee. She's going through a lot of big changes at the moment. One of those changes is a thing called transcription. Transcription, though it might be scary, is the process of making an RNA copy from a DNA template. Now, during transcription, all forms of the RNA are made using this process. The three forms of RNA are messenger, ribosomal, and transfer. There are 3 steps to transcription. The first is called initiation. This is where the RNA polymerase binds to a location on the DNA. This is called a promoter. Promoters signal the beginning of a gene. The second step in transcription is called elongation. This is where the RNA polymerase makes a complementary strand from one of the exposed DNA strands. Now, during elongation, a start codon is used. The most common is an AUG. Now, for some of you who don't know, a start codon is the first codon of a messenger RNA, also known as mRNA, translated by a ribosome. The third and final step in transcription is termination. This is where the RNA polymerase comes across a DNA sequence called a terminator, also called a stop transcription. This is where a stop codon is used to stop transcription. Now, messenger RNA is synthesized in the cell nucleus by transcription of DNA. This process is similar to DNA replication. As in replication, a small section of the DNA double helix unwinds, and the bases of the 2 strands are exposed. RNA nucleotides line up in the proper order by hydrogen bonding to their complementary bases on DNA. The nucleotides are joined together by a DNA-dependent RNA polymerase enzyme, and in result, mRNA is created and it can leave the nucleus. Another thing that's happening to Dee Dee is a thing called translation. Now, during translation, a messenger RNA is transcribed in the nucleus, and then it enters the cytoplasm and attaches to the ribosome. Now, during translation, a start codon occurs, an example being AUG. Each transfer RNA has an anticodon whose bases are complementary to a codon on the mRNA strand. The ribosome positions the start codon to extract its anticodon, which is part of the tRNA that binds methionine. The ribosome also binds the next codon and its anticodon. The next part of translation is when the ribosome joins the 2 amino acids, methionine and phenylalanine, and breaks the bond between methionine and its tRNA. The tRNA floats away from the ribosome, allowing the ribosome to bind to another tRNA, P and A. The ribosome moves along the mRNA, binding new tRNA molecules and amino acids. Now, during the completion of the polypeptide bond that occurred, the process continues until the ribosome reaches one of the 3 stop codons. This results in a complete polypeptide. Wait, stop! Look at Dee Dee! Oh my gosh! This could have only happened by a mutation. It could have been insertion or deletion. How are we ever gonna know? It must have been insertion. An insertion mutation is where a new base is placed in the sequence. This can alter the reading frame and every amino acid after the mutation is altered. What are we gonna do? She's gonna be pink forever. Those darn mutations messed up every amino acid sequence she had. Now we're never going to be able to read them to turn them back to the way they are. She's going to be pink forever.